Hello everyone. So now we'll start the exercise number 1.3. So before that, there is a theorem 1.3. If p is a prime number and p divides a square, then it is obvious that p will divide a also, right? Because a square means double of every factors of a, right? So if p divides a square, that means p will divide a also. So using this property, we can prove a number as irrational. So let's now start exercise 1.3. First question, we need to prove that root 5 is irrational. So first of all, to prove root 5 is irrational, actually what we need to do is we need to prove that root 5 cannot be written in the form of p by q. So what is rational? A rational number is a number which can be written in the form of p by q, where q should not be 0 first of all, and p and q must be coprime. Now what is coprime? Coprime are two or more than two numbers which have HCF 1, okay, like 8 and 9. These two are not prime numbers, so coprime are not necessarily prime numbers. Of course all the prime numbers are coprime, but coprime are not necessarily a prime number. 8 and 9 are what? Coprime numbers. Like, why? Because 8 is 2 into 2 into 2 and 9 is 3 into 3. So what is the HCF of 8 and 9? That is 1. HCF is 1. So when HCF is 1, two or more number having HCF is 1, that means it is coprime. Understood? So in this question, what we need to prove that root 5 cannot be written in the form of p by q, where p and q are coprime numbers and q is not equal to 0. Okay, so since we need to prove that it cannot be written in the form of this, so what we will do, we will assume that let it be written in this form. Then what happened? Then we will prove our assumption as a wrong assumption. Our assumption, we will prove it wrong, and then we will state that this cannot be written in the form of this. Okay, so for that the steps are like this. Let root 5 be a rational number, that is it can be written in the form of p by q, squaring both sides. This means q square is a number obtained from dividing p square by 5. That means p square is divisible by 5, right? And as per the theorem, we can state that if p square is divisible by 5, that means p is divisible by 5, right? So if p is also divisible by 5, that means we can write that p is something into 5, right? It is divisible by 5. It is divisible by 5. Therefore, we can say that 5 into something is equal to p. Let that something be a. Okay? Squaring both sides. Now let this be equation 1 and this new equation 2. P square equal to, there is a term, and there is also p square equal to another term. So obviously these two terms are equal, clearly from 1 and 2. Now in this statement, what does this mean? Q square is divisible by 5 into a square, right? That means q square is divisible by 5 because a square is some term which is obtained by dividing q square with 5. Therefore q square is divisible by 5. That means q is divisible by 5. Okay, which means p and q have at least 5 as their common factors. So since 5 divides q and 5 divides p, that means 5 is a factor of p and 5 is a factor of q also. Therefore 5 is a common factor between p and q. That means what? Our assumption that p and q must be coprime is wrong, right? This contradiction is, this is a contradiction, and this arises because of our assumption, which is wrong, that root 5 is rational number and therefore root 5 is irrational number. So the last line you will write that we conclude that root 5 is irrational. Okay, now let's go to the next question. Question number 2. Now this time we need to prove that this is irrational. So again we will take this number as a rational number. So this is same up to here, but in the next step we will take root 5 on one side and all the rest of the terms we will transpose to the another side. So we'll have root 5 equal to some term. And now we have taken that p and q are some integer which are co-prime. So since p and q are just some integer and q is not equal to 0, so obviously this term here is a rational term, right? This is a rational term, but we know that root 5 is irrational term. We have proved earlier. We don't have to prove it again here. So this, in this question, the difference is that we know that root 5 is irrational, and we will simply write that since this is rational term and this is equating with the irrational term, so it is not possible. Therefore our assumption that this whole term is a rational one, that is we have equated with p by q, that is wrong. So this part is rational, that will make this a rational number, and which contradicts the fact that it is a fact that root 5 is irrational. Therefore our assumption is wrong and this is a irrational number. Okay, so the rest of the questions are exactly same, and of course that is your homework. Okay, just remember one thing, question number 3 first part, 1 by root 2, when you will put this as a rational number and you will write like p by q, then you have to write the p and q both should not be 0, because this will reverse and it will become root 2 equal to q by p, right? So p cannot be 0, and in this case q cannot be 0, so both cannot be 0. You have to mention this part. Always remember this. Denominators cannot be 0, you know that from class 8.